Just a little reminder of some introduction to organic chemistry, specimen 0.5. Free radicals, remember free radicals, things like Cl2 in ultraviolet light will form radicals, 2 Cl dots. The dot is an unbonded electron that's come from the covalent bond between the two Cl's, the Cl2 breaking, and the electrons from the bond, one goes to one Cl, one goes to the other. That's your initiation step. And then it can react with things like alkanes, and here I've got it with ozone, O3, forming O2, and whatever's left over is ClO with a dot, so the unbonded electron now has gone onto the O. That reacts again with more O3 to form 2O2 and Cl dot, and that Cl dot, that radical, is very reactive and will react again with more ozone, causing a problem because it will deplete the ozone, and that might allow harmful UV rays to come through and cause things like skin melanomas, etc. So let's have a look here. So structural isomers, remember there's chain, position and functional group. This is where you have the same molecular formula but a different structural formula. Chain, where you're shortening the length of the chain and introducing branches. Position, where you're changing the position of a group, like say for example if you've got methyl pentane, the methyl group could be at carbon number 2 or carbon number 3, or if you had maybe propan-1-ol and propan-2-ol, the position of the functional group differs. And then functional group, maybe you've got an aldehyde and a ketone with the same molecular formula but a different structural formula, so a different functional group and a different name. Optical isomerism might come up. Enantiomers, how do you tell the difference between enantiomer and mirror images? They rotate plane polarized light in different directions. When do you get them? When you get chiral carbon in there, that's a group with 4 different groups attached to it. 2018 cracking then. So there's 2 kinds of cracking. Cracking using heat, so thermal cracking, using a temperature of about 500 to 600 degrees Celsius, so a high temperature and a very high pressure in the region of 70 atmospheres. That's 70 times atmospheric pressure. You tend to get things with double bonds, so alkenes, and there's another way of doing it. So you can use catalytic cracking using a catalyst called zeolite. This time you'll need a moderate or a slight pressure, so usually in the region of 1 to 2 atmospheres, so slightly elevated above atmospheric pressure. You still need a high temperature of about 500 degrees Celsius. The temperature hasn't changed that much, but with a catalyst you can get away with reducing the pressure from 70 atmospheres, 70 times atmospheric pressure, right down to just above 1, slight or moderate pressure, just above 1 atmosphere, just slightly above our atmospheric pressure. Again, here we've got an example of Cl dot formed from Cl2 going to 2 Cl dot in the initiation step, then going into a propagation step. Propagation step is where it continues on, and the Cl dot might react with something here. Say for example we've got butane, and it says that it wants to form 2 chlorobutane, so the H comes off carbon number 2 and leaves a C dot on carbon number 2. It always makes HCl, always, as a product, so it will make HCl if you're using Cl dot, and then the radical, the compound, the species with the dot, then reacts with more Cl2, and that's when you get your Cl bonded to make 2-chlorobutane, and you get a Cl dot made again. Remember, these are propagation steps, and then a termination step anytime when 2 radicals come together. to form something new. And we've got another one here, so I've got a chlorofluorocarbon. Remember, anything with chlorine in it can form radicals. So because the Cl can break off and make a Cl dot. And again, we've got something very similar to what we saw before. Cl dot and O3 forming ClO dot and O2. ClO dot reacting with more ozone to form Cl dot and 2O2. And the Cl is regenerated because which means that it's going to carry on reacting in something called a chain reaction.